The human brain is the most complex object in the known universe. Inside your head, about 86 billion neurons are constantly firing, sending electrical signals, creating your thoughts, memories, and consciousness. This incredible system is studied in neuroscience. But here's a question that scientists are still trying to answer. Is the brain only a biological machine? Or could something deeper be happening inside it? At the smallest level of reality, the universe follows the strange rules of quantum mechanics, a world where particles can exist in multiple states and even become mysteriously connected through quantum entanglement. This phenomenon was so strange that Albert Einstein called it spooky action at a distance. But what if these quantum effects don't just exist in physics laboratories? What if similar processes could be happening inside the human brain itself? And if that's true, could it change everything we think we know about consciousness? Are researchers able to explore quantum entanglement's potential role in neural synchronization? How microtubules could influence consciousness? However, this theory remains highly debated. Many physicists argue that the brain is too warm and noisy for delicate quantum states like entanglement to survive. So at the moment, there is no scientific evidence that human minds become entangled in the same way particles do. But the question remains fascinating. Even without quantum entanglement, humans experience powerful forms of connection. Emotional empathy. Synchronicity behaves like a web of relationships. Particles are not just things. They are connections. And humans are part of that same universe. Every atom in your body once existed in stars billions of years ago. You are literally made from cosmic history. So even if our minds are not quantum entangled, we are still connected in a profound way. Many physicists argue that the brain is not a good environment for quantum phenomena. One of the strongest critics is Max Tegmark. He argued that the brain is too warm, too wet, too noisy. Quantum states are extremely fragile. In such an environment they quickly collapse through decoherence. So traditionally scientists believed. The brain works through classical electrical and chemical signals, not quantum mechanics. A research team led by Yongsong Chen suggests a different possibility. They propose that quantum entanglement might naturally arise inside the brain structure. The key structure involved: myelin sheaths. Myelin sheaths are fatty insulating layers surrounding neuron axons, helping electrical signals travel faster. The researchers think these structures could act like tiny quantum cavities. Their theoretical model suggests the following chain of events. Step 1. Energy production in neurons. Inside neurons are mitochondria that produce energy. Chemical reactions there may emit infrared photons. Step 2. Photons interact with myelin. These photons may interact with carbon-hydrogen (CH) bonds in the myelin sheath. This interaction could trigger cascade radiation. Step 3. Creation of entangled photons. The cascade process might produce biphotons. Two photons created together. These photons could become quantum entangled. What entanglement could do in the brain? The famous physicist Albert Einstein called entanglement spooky action at a distance. Just said before in a video. Because two particles remain correlated even when separated. If this happened in the brain, neurons in different regions could coordinate instantly. Synchronization across large networks could become faster. Cognition could become more efficient. In theory, this could help explain rapid neural synchronization, unified perception, possibly aspects of consciousness. The researchers used a framework from physics called far. No direct experimental proof exists. The current scientific position. The scientific community remains cautious. Most neuroscientists still believe brain cognition is classical physics. Neural synchronization arises from electrical signaling. But a minority of researchers think quantum biology might play a role. Why this idea is so fascinating? If proven true, it would mean the brain might be partly a quantum system. This could change our understanding of consciousness, cognition, neural communication, artificial intelligence. It might even connect neuroscience with quantum physics in unexpected ways.